Hi, this is a hands-on science experiment for elementary school students. It's part of the www.resetonline.org volunteer program. And this has to do with water treatment and wastewater treatment. Usually I'll open each session by introducing the vocabulary words, but we need to do a little bit of setup here ahead of time because part of the experiment takes about 40-45 minutes. So what I have in this bucket here is polluted water, and made that by throwing in garden soil into the water and stirring it around so there's plenty of solids available in this water. So what I do is I'll have the students take a transparent 8-ounce glass and fill it with the polluted water and just set that aside and let it sit for a while. Usually I'll try to let it sit for 35-40 minutes before we get back to that. The vocabulary words for this particular session: sedimentation or settling, sand filtration, pollution, water treatment, and waste treatment. I'll talk a little bit about how water gets to the schools and the houses, and sources of pollution such as those that come from houses, down the drains, flushing the toilets, from schools, from factories, and how we need to clean up the water from the rivers in streams and lakes before it gets to people's houses and to other uses. And then we clean it up again before it goes back into the streams, lakes, and ponds. This is a transparent plastic tube I use to demonstrate how sand filtration works. It's about probably around 16 to 18 inches tall. I get these are long fluorescent bulb protectors. You can order them online. If you order them with end caps, that's good because that it provides a place to hold the sand and for the water to drip through the plastic tube. And I put a piece of fabric over the slot in the end cap so that the sand doesn't wash out as part of this experiment. So if we place that in another glass, and if we get similar to the first 8-ounce transparent, get another cup of the polluted water, pour it into the top of the tube, and we'll let that sit for a bit as well. I will usually have a student hold on to this because it's a little bit top heavy and it'll fall over. That then proceeds, I let that go on probably, well, we'll see how quickly it works its way up through or down through the sand into the glass. The sand I'm using here is coarse sand like that's used in making concrete. If you use the fine sand, the very almost powder-like sand that you find on some beaches, it's a little bit too tight in terms of lacking pore space for the water to work its way down, so it takes too long. So this coarse sand will not produce water as clean as a finer grained sand will, but it's doable within the time frame that we've scheduled for our 45 to 60 minute sessions. So what we have here is settling going on. What we have here is sand filtration going on. I'll talk about treatment plants and how that in a treatment plant that treats the water before it gets to your house, they may have sand filters that are the size of the classroom, filled maybe 6 feet deep with sand, and they put the water taken out of the river on the top of that, on top of the sand, and let it trickle on down through the bottom. In both water treatment facilities and wastewater treatment facilities, settling is a process that's used to remove solids, and talk a little bit about the gravity force that pulls the soil or the waste particles down to the bottom of the tank, in this lab case to the bottom of the glass. I've worked with the kids on gravity before, and you can, if you want to, also just you'll find floatables in the top of the glass. You can talk about buoyancy that I've covered in the floating and sinking experiment as well. For purposes of this, I usually net the floatables out of the polluted water ahead of time because it tends to confuse things a little bit in terms of how the sedimentation or the settling works. I'll just these I set aside about 45 minutes ago. So this is what these apparati will look like after about 45 minutes. Then I'll have the students get one more glass of polluted water out of the bucket. Stir it around to make sure there's sediment in the polluted water. And then I'll have the students compare the water in each of these three glasses. This is the water that's gone through the sand filter apparatus. This is the water that's been settling, and they can hold that up to the light and see the layer of solids at the bottom of it. And then this is the fresh polluted water we just removed from the bucket here. And they can see the gradation of the levels of pollution in each of the three cups. I usually have each group of students, 4 or 5 students, set up with this various apparatus, and so they each group will do the same thing using 4 or 5 of these tubes and numerous glasses. I'll then have each team of students, this is a graduated cylinder, pour into it the water from the sand filter and observe where it goes to on the scale. This goes up to about this goes up to 90 milliliters, and then I'll have them pour it through a paper towel that I've inserted into a glass. Pour it through slowly so the water will drain through the paper towel. And then I will have them take the water that has been settling for about 40 minutes, pour in the same volume from the top. Do it rather carefully so you don't resuspend this sediment that has settled out during the 40-minute interval. I tell them that usually in a settling tank in a treatment facility, the settling time is about an hour. Pour that through a similar, I just had the students use the same cup and change out the paper towel, but in the interest of this video, I used 3 different cups. Then take the water that is the most polluted, hasn't had any settling, hasn't had any filtration. Fill the graduated cylinder up to the 90 milliliter mark in this case, so that we're filtering similar volumes of water in each of the 3 paper towels. Then use the paper towels to illustrate to the students how much pollution was left in the water. So the sand filter